What is the Singleton Design Pattern? How do you use it? And why is it important? These are all great questions. In this video, I'm going to answer all of them and more. We're going to take a look at one of the more popular patterns in the Gang of Four set. Now, in case you haven't watched my videos before, my name is Tim Corey, and my goal is to make learning C# easier. My goal isn't to entertain you. It's to turn you into a world-class developer. I do that by making sure that everything I teach focuses on preparing you for the real world. If you have thoughts on what you'd like to see me cover in a future video, let me know down in the comments and I'll be sure to add it to my suggestion list. Okay, let's go to Visual Studio and we're going to start with a really simple project. So a new project, we're going to use a console application. We'll start here just to see how to set up a singleton on our own, basically without anything else helping us do it. We're just going to create it on our own class as a singleton. So let's go to console app and we'll hit next. And we're going to call this console UI is fine. And we'll call this singleton demo. We'll hit create. And we're not going to run code necessarily. We'll run a little bit of code just to see how it works. But this really is a focus on the singleton pattern. So let's start by creating a class that's kind of a setup. Okay, so we're going to create a class that is not a singleton, that is going to kind of illustrate why we need a singleton. It's kind of more like one of those things where you see something and it helps you understand why you use something. So let's create a class. Right click on console UI and say add new class. And the class, we're going to call this, let's call it table servers. Okay. And what this class is going to represent is, let's say we own a restaurant. And in this restaurant, we have waiters and waitresses who wait on tables. So a new customer or set of customers comes in. They're going to ask for a table. And that we're going to assign a waiter or waitress to that table. We're going to say, okay, that's your table to deal with, to handle. And that's going to be in a rotating fashion. That way we don't exclude one waiter or waitress from the rotation and they don't get any tables and thus no income or no additional income. So therefore, we're going to have this class and it's going to handle making sure we give out the rotation properly. And this is going to be a really kind of, you can do this better probably in C#. This is an illustration, okay? So bear with me if it's not the ideal solution for this. It's an ideal solution, I think, to demonstrate the purpose of singletons. So make it public. And then in here, let's create a list of string. So a private list of string, and this is going to be servers equals new list of string. And then in our constructor, so CTOR, that's a snippet. We tab twice and it creates the constructor snippet, or creates a constructor from the snippet. So in here, we're going to say servers.add. Let's start with Tim, and then servers.add Sue, and then we'll do Mary and Bob. Okay, good short names. I like short names because it's easier to type. So I have now these 4 people who are servers. They're wait staff for the table. And what I'm going to do is I'm going to have a method in here. So we're going to create public method, oops, not public method, public string, and we'll say get next server. And what that's going to do is return the next person in line, which means we have to have some kind of counter or way to identify which number we're on. So private int current server equals 0. And that's going to be the next server we give out. Let's call it next server instead of current server. So this is the next server. So it's the index this is the index we're going to pull from this list. So what we're going to do here is return server at this position. So we're going to say, let's capture it first. So string output equals next, servers at position next server. Okay, but then we got to figure out how to increment that value. So we're going to say next server plus equals 1. So we're going to add 1 to it, but then if next server is greater than or equal to servers.count, then next server equals 0. That's where you loop back to the beginning. So it creates this constant rotation. So if we have 0, 1, 2, and 3, so when next server says 3, we'll capture that and put it as Bob. But then we add 1 to it, it's going to say 4. Well, there is no item at position 4, but the total count is 4. So therefore, if next server is greater than or equals count, and since it will equal count, then we're going to set it back to 0. So the next server would be Tim again. So that's how we loop back to the beginning. Okay, and we'll return output. We do it in this order instead of returning this because we want to make sure we change the number after we capture the name. So that's why we're doing it that way. So this is our little class. It just tells you who's up next. That's all it does. So if we go back to program.cs and let's get rid of this, and I'm going to say table servers equals new table servers. Now let's do a for loop. And we'll say for I is less than 10. So 10 total servers we're going to ask for. So let's do console write line, and we're going to say servers dot get next server. All right, it's going to loop through, and let's add a string at the beginning. The next server is like so. I couldn't do string interpolation here, but that works as well. And at the end, we'll do a console read line just to make sure that we don't close out of our console. All right, so let's just run this and see what it does. It should loop through and give us all of our servers. Okay, Tim, Sue, Mary, Bob, Tim, Sue, Mary, Bob, Tim, Sue. So that's exactly how you want it to work. It's going to rotate through our servers, giving us the next person who's going to serve a table. Okay, so that's all well and good. But let's refactor this a little bit. And we're going to say private static void, let's say host1 get next server, like so. And yes, this isn't a perfect code because I want to refactor this since I have two of these, host 1, host 2. I want to refactor these in a different way, but let's just go with the fact that this is how we're going to set things up. So host 1 is going to get the next server. So console.writeLine, and let's actually write out the same thing, only we don't have that instance. We actually want to create an instance. So let's just say that host 1 has their own list. So table servers, let's say static table servers, host 1 servers equals, or host 1 list equals new table servers. So this is, if you have, let's say you have two hosts that are standing at the platform or a podium, and as people walk in the door, they greet the people, they figure out which server is going to serve them, they take them to the appropriate table and seat them. But you don't want that podium to be empty because there are more people probably in line coming. And so you have two hosts. And the next host steps up, gets the information to the people, waits for the host 1 to come back, and then they take their group, host 2 takes their group to the tables while host 1 steps up, and it's that kind of rotation. Well, each host will have their own scratch pad of who goes next. So we're going to create two scratch pads. one for host 1 and one for host 2. So host 1 get next server, the next server is host1 list.getNextServer. Well, we're going to create another method that is host2 getNextServer, because that host 2 just walked up the podium, and they're going to consult their list and get the next server. So let's simulate that. Now, for the sake of simplicity, what I'm going to do is in my for each, let's change it to 5 just so we don't overwhelm things. I'm going to say host 1 get next server and then host 2 get next server. So we're doing both inside the for. That just simulates that 2 of them, one walked up, got the next family coming in, assign them a person. The next host walked up, got the next family coming in, assign them a person, and then it repeats. Okay? Let's see what happens in this situation. If we run this, the next server is Tim, the next server is Tim again. Then Sue and Sue, then Mary and Mary, then Bob and Bob, then Tim and Tim. That's not right. We don't want that. That's not how the rotation is supposed to work. And you could say, well, you can then, instead of having 2 lists, you can create 1 list. Cool. Except for the fact that right now, this is all inside of our program class. But what if we had a list somewhere else? How do we make sure that those lists are synchronized? How do you make sure that we don't have Tim get 2 tables in a row? Because that's unfair. Well, the way to do that is to use the Singleton pattern. So let's do this. So we have a record of this. Actually, you know what? No, we're going to switch it all over. So we're going to switch over table servers. So if you have to, take a screenshot of this. If you want this code the way it is right now, take a screenshot right now, because I'm going to update it to be a singleton. So it's going to change how things work. So let's start by changing our constructor to private. You might say, well, Tim, that's how you create a new instance of table servers. Yes, it is. And it's private, which means only things inside this class can instantiate this class. That's correct. So how do you instantiate that class? I'm glad you asked. Let's come up here to the very top, and we're going to say private static, and static is very important, read only, and we're going to create an instance of table servers. That's the class we're in right now. And we'll call this, let's call it instance, equals new, because we can create a new instance of it because of the fact that we're inside this very class. Now this is static and read-only. Why are those important? Well, read-only is important because that means you can't overwrite this variable with something else. Once it's assigned, it can't be reassigned with a new value. Now, static is important because if you remember with your object-oriented programming and how classes work, typically you think of classes as being instantiated, meaning you have to say equals new class name in order to create an instance of that class. We also have a static keyword, and the static keyword basically says you can access this without having the class be instantiated. But it's private, so we can't yet. No worries, we're gonna get there. Down below our constructor, let's create a new method. We're gonna make it public, again static, and we're gonna return an instance of table servers. And we'll call this get table servers. Okay, so this method is static, which means, and it's public, so you can call this method by just saying the class name dot the method name. Well, this is going to return instance, which is that private read-only instance of our class instance. So the only way to instantiate this class is right here. That's the only way we're going to do it. We instantiate it right here. You can only do it privately, so only in this class. So we create one instance. But when do we create this instance? Well, we create this instance as soon as we start using this, meaning it's not created until we need it. It's a lazy instantiation. So it's going to wait until it's needed. But once it's needed, we're going to create a new instance of this table server. So that would be the instantiated version. So not only we have access to the static things, but also the non-static things like this get next server. So when you say get table servers, you're going to get an instance of table server. But which instance? You're always going to get the same instance back. This first instance that gets created. So therefore, everyone gets the same instance, which means everyone has access to the same data with the same values. Let's look at how this would work. Let's go over here. We can't do equals new table servers. What we can do instead is we can say table servers dot get table servers. This gets an instance of table servers, and it gets the same instance. So you do the same thing right here, which we're not actually using this right now, but now we can do is run this same code over again. Now we've created a singleton. Let's run this. And now it says Tim, Sue, Mary, Bob, Tim, Sue, Mary, Bob, Tim, Sue, like it should, like we're expected to. So what happened that was different? Well, these two requested an instance from table servers, and they got the same instance. So when we call this right here where it says get the next server, host 1 list is the same as host 2 list. Therefore, get next server increments that I value, that counter value, and then this one has that new updated counter value, and so it gets the next one in line. Now again, I could have given the same instance to both of these without using a singleton. However, if I have a method somewhere else in my application that also asks for get table servers, it now will get a new instance, or the same instance, not a new instance. So if I want to do a kind of singleton pattern without using the singleton pattern, what I could do is create an instance and then make that instance a global variable and everything point to it. The problem with that is that now everything's pointed to this variable. You have to remember where the variable is, and you might accidentally create a second instance. That's not terribly safe. With this pattern, where you can't call the constructor directly, so you cannot instantiate it directly, you have to go through this method. With this method, no matter who calls this class in this particular class in program.cs or a totally different class somewhere else, no matter who calls it, they're all going to get the same instance of our class. Now at this point, you probably have one of two reactions if this is a newer pattern for you. The first reaction you might have is, this is awesome. I'm going to use this all the time. I would encourage you not to. This is a limited use pattern. But let's talk about the other response first, and then we'll get back to this response. The other response is, this is stupid. I would never use this. I'll just create I'll create a global instance and point to it from everywhere. And to that I would say, don't do that either. Okay? So there's a meeting in the middle you have to have in your code. I don't use a singleton instance very often. But when I need to, this singleton design pattern is really helpful. And the reason why I don't use it very often is because I don't want to have this kind of data globally. Because remember, this is lazy loaded, but as soon as you start using this, this instance will get created. Once that instance is created, it will not get destroyed for the life of your application. That means as long as your application keeps running, this instance will stay open. That can be especially problematic if you're on a web server, for example, because typically you don't restart your web server that often, which means that if you have one of these, not a big deal. But if you have 100 of these or 1,000 of these, all of a sudden your memory is filling up with stuff that's just probably shouldn't be there. Okay? So you got to make sure you're very selective about when you use a singleton. You don't want your memory just stuffed full of these instances, especially ones that hold data, that you don't necessarily need to have open all the time. On the other end, there are times when you need to share data across your entire application, and it makes more sense to have the data in memory than it does to load it continually. So for instance, maybe you have certain configuration data. Now, if you've watched my C# application from start to finish course, which is on YouTube, it's a playlist for that. In that course, there's a little bit of data that I wanted to have accessible across the entire application for the life of the application, because I thought it was more expensive to continually load that data up. And that's more expensive than just storing it once in memory and just accessing it. And so I chose to create something like a singleton pattern, but it wasn't a singleton pattern. I was trying not to add too much confusion because design patterns can be a little confusing. For instance, this pattern, that might take you a little bit to understand the private static read-only and the private constructor and the public static method to get an instance. I get that that might take a few minutes to wrap your head around. So I tried to limit how I did that. But that's the kind of thing that I once in a while need, is a little bit of data that I'm going to access over and over and maybe even change once in a while, that I want to have access to pretty much everywhere, in which case a singleton is a great option. Now, this singleton instance is designed to store data. There are some times when you create a singleton instance where it's not designed to store data. And we're going to look at that in just a minute. And usually that has to do with working with dependency injection. So let's create a new project here just to see a singleton in action. So let's right click on our solution and say add new project. We're going to go right down to the more modern application, Blazor web app. And we're going to call this Blazor server is fine. And we're going to say a Blazor server app. No other changes here on the right. And in here, we're going to see a different way to use a singleton. So here's our Blazor server project up here. If we go to startup.cs, this is where we configure our services. Now this is dependency injection. What it's doing is it's saying when you ask for a certain thing, here's what to give it. Okay, so when you ask for, in this case, weather forecast service, create a singleton of that weather forecast service. So let's look at that weather forecast service. The weather forecast service has a private static read-only string that has our summaries, and then the get forecast async method. So there is no storing of data in this class. So why is it a singleton? Well, we're going to use it over and over again to call this method. We don't want to mark it as static because that adds some other complexities we don't want in this case. So instead what we do is for our dependency injection system, this has to be instantiated. You have to say weather forecast service test equals new weather forecast service. But in our configure services, when we say give us an instance of the weather forecast service, what we're saying is give us a singleton of that weather forecast service. So when the first person asks for weather forecast service, they get a new instance. When the second person asks for weather forecast service, they get the same instance that person one got. So it behaves the same way without having to write this code here. Okay? So with our dependency injection system, we can sometimes get around having to write all this extra code. This extra few lines at least. But, and here's the downside. Do you have to say singleton right here? Well, no. You could say add transient, which means it'll create a new instance for every call. You could also, somewhere else in your code, directly reference the services and say, weather forecast service test equals new weather forecast service, and that would work. So while dependency injection does allow for and use the singleton pattern without having to add extra code to your class, it's not quite the same as the actual Singleton design pattern. It returns a singleton, meaning the same instance, but it does not really adhere to the Singleton design pattern. Okay? I hope that makes sense. There's a distinction there. So, if you think this is stupid, there are places to use it. There are places and times like this right here where it makes sense to make it a singleton. If you think this is awesome and you can't wait to use it everywhere, remember you're storing all of this in memory. Now, that's no big deal. Okay? One class instance with 4 names in it is not a huge deal. But remember, this probably isn't how you're going to get these names. You'll probably load them from a database. And maybe they won't be servers, maybe it will be orders. Well, that might not be just 4 or 10 or 15. That might be 100 or 1,000 or 10,000. Who knows? So in that case, you've got a lot of memory being used just holding on to this information. You might be better off using a different mechanism to get the data. Maybe, for instance, you store what the last server was, and what their ID was, and then you do a database lookup every time for the next person in line, where you're kind of offloading that storage of people's names to the database, and you're just saying, I'm okay with making a database call every time. That might be lower in terms of your performance hit. So this is a balancing act to make sure that you don't just say, I'm going to use this all the time, or I'm never going to use this. Use this as one more option in your toolbox to lower the performance hit of a certain action, or mitigate a performance hit by allowing this to stay in memory long term. Just make sure that the cure isn't worse than the disease. Okay? So that's the singleton pattern. I would encourage you to try it out. Practice. Maybe if you have a little test app, add a singleton pattern somewhere and just see how it works. And either way, create a new project, try it out, and maybe follow along and do exactly what I did or something similar and just see what your results are. Play around with it, okay? Thanks for watching. If you have any questions or comments, leave them down below in the comments. I'll be sure to read them and respond appropriately, okay? Thanks. As always, I am Tim Corey.